Hi, welcome to this next video in the series of business and finance maths. Now we're going to take a look at how to use E. We defined it in a previous video. Now we're going to see how we can use E to solve some problems. So on the screen there we can see a problem which is typical of the type of problem you might have to solve. The percentage of households having at least one smartphone at time t in years after their introduction to a country has been modelled by economists to be. And then you get a simple formula which contains E. Y equals 100 minus 95 times E to the minus 0.15t. So straight away, before we even begin to work with the numbers here, it should be clear that the number or the letter T here is going to produce some interesting results. And that is as we increase the value of T, we're going to make the exponent smaller and smaller. So this is going to get smaller and smaller as T gets bigger and bigger. And if that bit gets smaller and smaller, then so does the whole piece with the 95 in it. So as time goes on, we'd expect this piece here to get less and less. And in the end, we'd expect to see 100% of households having at least one smartphone sometime t after it begins. So that's just to show that we can predict just from the equation what might actually happen. I'm going to delete that now. We're going to see it happen with some real numbers. Let me just clean that up. So let's just do one or two by hand and then we can let Excel take the strain. So here Y equals 100 minus 95 E to the minus 0.15 times 0. That's the first one here. T is 0. 0 times minus 0.15 is 0. E to the power of 0 gives you 1. 1 times 95 is 95. So the final result comes out as Y equals 5%. 100 minus 95. So a low coverage right at the beginning. If we take on the 10-year model, we get 100 minus 95e to the minus 0.15 multiplied by 10, or 100 minus 95e to the minus 1.5. Now, to solve problems with E, you'll need to look on your calculator for the key that has this symbol on it. And each calculator works these out slightly differently, so you'll need to become familiar with your calculator's handbook when you're working with the E to the X button. So let's actually do that. When we put this into a calculator and work with it, we are going to get a value out equal to 78 point, I think 8 is it? Yes, 78.8. So after 10 years, you can see that we've increased our percentage cover from 5 up to 78. And if we actually now just bring in a list of the numbers that we complete in Excel and put them into the sheet here. Here we go, straight in from Excel. We can see what happens as you increase T. If we went to the next one up, 30 years, it would, or 40 years or 50 years, you can see that the results are, let me just lock this into place, the results are going up. And it should be clear that, if I could actually draw straight, that in the end, the figures are going to reach 100%. Okay, so it's a continuous change. People are buying and selling their smartphones all the time. There's no fixed point where to start, no fixed point where to end. So that's what we mean when we say we're modeling a continuous change. We don't have a specified start time or an end time, but as we're going through, we can say that the change appears to be more or less continuous, and we can develop a model of what that actually looks like. So in the case of the smartphones, the economists produced this model up here, and for every country and every product and through different times, you're going to get different numbers here to represent what's actually happening. So in the next video, what we'll actually do is look at how we can come from a set of data, information that we collect in an environment, to produce for ourselves a model that we can use to make predictions or to analyze. But before we finish, I'm just going to bring in a little picture here. This is from Desmos, again, nice software for this kind of thing. And here we see the actual shape of the curve, where down here, we can see down here, it's at the 5 that we predicted. Up here, we have the 100% line in blue dots, and then gradually going up, but getting less and less steep, the percentage of households with at least one smartphone in them. And up here, you can see that all I've done in Desmos is type in a representation of the formula, and this bit here just represents the domain. So it's only plotting those values between 0 and 50, and then it stops. You can see it's stopped up here. Okay, so that's enough on that bit. In the next video, what we'll do is we'll look at how we can take a set of data and convert them into a model using E. So that's the end of this video.